Today you're going to be starting lesson 9, the revolve and sweep features, and you're going to make a beautiful candlestick holder and a candlestick, and then you're going to make an assembly out of the two of them. You're going to see, you go to your building models, revolve sweeps in the tutorials. So when we go to SolidWorks and you open that up and you go to help, you go to tutorials, all right, you're going to be looking for your revolve sweeps, which is right here. So it's under basic techniques, revolve sweeps, and then you're going to follow these instructions on how to create the candlestick holder as you watch the video. So all that information is there in your help SolidWorks tutorial section. And then you're going to make the candlestick according to these directions. You're going to make an assembly out of the two of them. You're going to, you can skip this section right here. You could skip that. Then you're going to make your own coffee mug. All right, design and model a mug. You're going to make this from scratch. So you can make it complex design or you can make it a simple design. That's up to you. And then you're also going to make this top right here. Okay, so you got 1, and then you got 2, and then you got 3. You got 3 drawings. One is the assembly of the candlestick and the candlestick holder. One drawing is the mug that you created from scratch, and the other one is the top that you create. So let's go into our PowerPoint presentation. And this is lesson 9. Revolve feature overview. A revolve feature is created by rotating a two-dimensional profile sketch around an axis of revolution. Right? The profile sketch can use a sketch line or a center line as the axis of revolution. All right, so you can have a center line that's drawn here, and then you can have this feature revolve around the center line, or you could have an actual line on the drawing be what it revolves around the rest of it. All right, so but you can't have a sketch revolve halfway around itself. Okay, so you can't have your center line in the middle or through any part of the sketch that you created. That wouldn't work. All right, so select the sketch plane, sketch a two-dimensional profile. So if you follow your directions in your tutorials, this is what the two-dimensional profile on the front plane of the candlestick holder would look like. And then you will start on your center or in your point here, and then you're gonna revolve around this line. You can also revolve around the center line. All right. Sketch a center line. So here's a center line that was sketched. The axis of revolution must be in the sketch with the profile. It cannot be in a separate sketch. The profile must not cross the center line. So notice how here's the center line, and nowhere does the profile go across the center line. You click the revolved boss base. All right, so you pick your line, be a center line. It probably wouldn't be line 1, but it could be line 1. Specify the angle of rotation, so we're going to have it at 360 degrees. The sketch is revolved around the axis of revolution, creating this feature. So here was our original profile, and then as it was revolved around it, it creates this round base feature. A 3-point arc creates an arc through 3 points to start, end, and midpoint. All right, to create a 3-point arc, click on the 3-point arc on the Sketch Tools toolbar. All right, point to the arc start location and click left mouse button, draw it down. So when you create this, you can use a 3-point arc to create an arc. And I've shown people how to use 3-point arcs already this year, so it shouldn't be anything new to you. Move the pointer to the arc to the end location, which would be about here, length of 20. And then click the left mouse button again. And that allows you to set the arc and then pull it out. Drag the arc midpoint to establish the radius and direction, convex versus concave. All right, so here we have our radius of 10. Click the left mouse button a third time, and that sets the arc. The tangent arc tool creates an arc that has a smooth transition to an existing sketch entity. This is not tangent, right? This is tangent, so it's a smooth transition from the straight line to the curvature. This is a bump. Boop. Saves the work of sketching an arc and then manually adding a geometrical relation to make it tangent. Start point of an arc must connect to an existing sketch entity. This one's not tangent either. You can also use the features. You can add relations and add. You can turn either one of these into tangent by having add relations. Click tangent arc on the sketch toolbar. Point to the arc start location. Click the left mouse button. Drag to create the arc. The arc angle and radius values are displayed on the pointer when creating arcs. So here we have an arc being created, and it shows the radius, the center of the arc, and the radius coming through. Click the left mouse button, and your arc is created, and then an arc is tangent to an existing arc. So if you put one arc to the other, you can have it tangent to that arc. Tangent to this line, tangent to the arc. As you sketch, the pointer provides feedback and information about alignment to sketch entities and model geometry. All right, it can show you horizontal, vertical, parallel, perpendicular, tangent, midpoint, intersect point, endpoint, vertex, or center point, and on line. Dotted lines appear when you sketch, showing alignment with other geometries. So we should be familiar with this now. You don't want to lock in positions on alignments. You want to make sure you can use the alignments correctly. This alignment information is called inferencing, showing the alignments. Inference lines are two different colors, blue or yellow and blue. So here's a blue line, here's a yellow line. Obviously this is blue, that's yellow. Yellow inference lines captures and adds a geometry relationship such as a tangent. Blue lines show alignment and serve as an aid to sketching, but do not actually capture and add a geometric relationship. Used to create the ellipse sketch tool, used to create a sweep section of the handle of a candlestick. All right, an ellipse has two axes, major axis labeled A at the right, minor axis labeled B. Sketching an ellipse is a two-step operation similar to sketching a three-point arc. Click Tools, Sketch Entity, Ellipse. Tip: you can use tools, customize to add the ellipse tool, looks like this, to Sketch Tools toolbar. Position the pointer at the center of the ellipse. Right, so here's the position. Click the left mouse button and then move the pointer horizontal to define the major axis. So this is a this is a circle. If you want to make it an ellipse, you have to squeeze it in either this way or that way. Click the left mouse button a second time. Move the pointer vertical to define the minor axis. So you can see like a three-point arc. Now you can squeeze and move this back and forth. Click the left mouse button a third time. This completes the sketch of the ellipse. All right. Requires 4 pieces of information. Fully defining ellipse. Location of the center. Either dimension the center or locate it with a geometric relation such as a coincident. Length of the major axis, that's the longer axis. Length of the minor axis, that's the shorter axis. So the major axis is 3.250 and the minor axis is 2. Orientation of the major axis. Even though the ellipse at the right is dimensioned and its center is located coincident to the origin, it is free to rotate until the orientation of the major axis is defined. So you can wiggle it around. Wiggle, wiggle. The major axis does not have to be horizontal. You can dimension half the axis and or minor axis. It is like dimensioning the radius of a circle instead of the diameter. So here's a major axis being up and down and the minor axis being horizontal. So major axis vertical. You could also have the major axis at an angle and the minor axis at an angle. You do not have to use the geometric relations to orient the major axis. A dimension works fine. You have 45 degrees right here. The trim tool is used to delete a sketch segment. The segment is deleted up to its intersection with another sketch entity. The entire sketch segment is deleted if it does not intersect any other sketch entity. You click on the trim tool on the sketch tools toolbar. Position the pointer over the sketch segment. So this was a long line, but if I hit the trim tool and trim to closest entity, then it'll take out what's in between these 2 points. The segment that will be trimmed is highlighted in red. There it is. Click on the left mouse button to delete the segment, and then that'll disappear. The sweep feature is created by moving a two-dimensional profile along a path. So we created an ellipse, and then we created these lines and arcs. A sweep feature is used to create the handle of the candlestick. So we were able to sweep from this ellipse all the way out to the end of the handle, as you see here. The sweep feature requires 2 sketches. A sweep path, this is the line, and a sweep section, that's the ellipse. You can see the ellipse was pulled all the way out to the very end. The sweep path is a set of sketch curves contained in a sketch, a curve, or a set of model edges. The sweep section must be a closed contour. The starting point of the path must lie on the plane of the sweep section, right? So that ellipse was a closed contour. The section path of the resulting solid cannot be self-intersecting. Sweep tips. Make the sweep path first, then make the section. Create small cross sections away from other part geometries. Then move the sweep section into position by adding a coincident or pierce relation to the end of the path. You're gonna learn this as you create that candlestick holder. You can watch the videos on how to do that also. Open a sketch on the front plane. Sketch the sweep path using the line and the tangent arc sketch tool. So we have the front plane, and then you draw this. This is a line, and then these are curves or arcs. Dimensions as shown. Bing, bang, boom. Close the sketch. Very important, you close the sketch. Open a sketch on the right plane. Sketch the sweep section using the ellipse sketch tool. Add a horizontal relation between the center of the ellipse and one end of the major axis. Dimension of the major and minor axis of the ellipse. The minor is 10, the major is 35. Add a coincident relation between the center of the ellipse and the end point of the path. So you're going to have an add relation, and you're going to, this little green dot, you're going to click on that, and then you're going to click on that, and then you're going to add a coincident relationship between the two, and that'll take this and put it right on the end of that line. And then it appears right there. Then you close the sketch. Then you click the sweep on the feature. You have your ellipse, and then you have your line. Select the sweep path sketch. That's the ellipse. Select the sweep section sketch. That's the lines, the arcs. Click OK, and bada bing, you're done. Now you have to cut with an angle. All right, create the opening for a candle in the top of the candlestick. Same process extruding a boss, except it removes material instead of adding it. Draft tapers the shape. Draft is important in the molded cast of forged parts. All right, for an example, ice cube tray, without draft, it would be very hard to get the ice cube out of the tray. Find other examples. That means that it's angled inwards. Open a sketch on the top face of the candlestick. So you click on that, and then you open your sketch, and then you create a circle concentric to the center of the candlestick holder there. Dimension the circle, and then use your extrude cut on the features. All right, so we have blind, we have a distance of 25, then we add an angle in here. End conditions. Type is blind, depth is 25, draft is on, angle is 15 degrees. Then click OK. Bam! There you go. The fillet are used to smooth the edges of the candlestick. Selection filters help in selecting the correct geometry. All right, there you go. Click this little selection filter here, geometry, to turn the selection filter toolbar. Use the edge section to filter. Pointer changes appearance when the filter is active. And then you're going to fillet this and that and this and that so that it looks so beautiful. All right, so best practices. Keep it simple. If you had a circle here, all right, do not use the sweep feature when a revolve or extrude will work. So revolve, here's a sweep. Sweeping a circle along a circular path appears to give the same result as a revolve feature, right? So this is a circle, then it was revolved around this axis, and then this is a sweep, this is a circle, then a line is drawn in a circle across it into center, and then it's swept through the same position. However, the revolve feature is mathematically less complex, is easier to sketch one sketch versus two. So this is easier to do for the computer and the rest of it. Easier for you to do also. The end.